Welcome friends, welcome to the training of Power System Production Fundamentals. So we will start our training. Let's start with how a day's power systems look like. Basically, the modern power system is a more complex power system. You can imagine many power plants and substations are connected together to a network through a transmission line. You can see these are the one power plant, a thermal power plant, then we have a hydel, then we have also nowadays you can see the storage system where power can be stored in the batteries. This is more important where we have for example solar systems where we can generate a lot of powers in the daytime, and in the night time we can use it the same power if we can store it in some kind of battery. And when the power is collected, then this is transmitted through transmission line to the load centers. For example, normally you can find the hydel power plants are away from the load centers in the mountain area. Nowadays China is building a HVDC project, and using this HVDC project they will transmit 8,000 megawatts of electricity from a remote area in the mountains to the load center and located almost 1,000 kilometers away. And the sending and HVDC substation is LCC, whereas the receiving end has two VSC substations. So this is one of the very unique and also a rare combination. So power control will be done especially at the LCC end. So nowadays network is becoming more and more complex, and more and more you can see the HVDC transmission lines, because now electronics powered electronics is getting cheaper, and it's now more advantage to use HVDC. So you can see here the renewable system, the solars. Nowadays solar system is also installed. The solar power plant can be of 50 megawatt to as maximum as to 300, 500, 800 megawatts. The power fuel cost is almost zero because it's coming from sun. So there is a cost which is only related to running cost and maintenance cost. This is something similar like a hydel system. And then the voltage is step up at the generating end in AC transmission. It can be AC transmission usually is happening at low voltages, and then further it is then converted to from several kVs to 132 kV, 220 kV, 500 kV step up transformers are connected, and using a transmission line these are transmitted to the remote load centers, and where again using the transformers the voltage is stepped down from, for example, 500 to 220 and then 132 kV, and further it is stepped down to the utility distribution voltages of 11 kV. In some countries it is 33 kV, and then further it is stepped down to domestic voltage level of 400 or 110 volts, and different in different countries. So in this way all the network is connected. Nowadays you can see a new concept in which each domestic level they have allowed to install the solar plates, and even they can export the power back to the utility, and they have introduced the smart metering. So this is the new concept. So what was in earlier days of the power system, the earlier days of power system was like there used to be a transformer, there used to be a power plant, and with the power plant there used to be a substation, there used to be a station which has the job to further step down the voltages or step up the voltages to take it to the load centers. That's why the station which are a power plant was called as station. the power station, and the small substation or the station which is connected, which has only the switch gear or switching devices and the transformer, used to called as a substation. So that's how the name sub came out. So this was the initial power plants, and the initial power plants were not connected together, like different regions, different cities were not connected. Each city, each region were used to make its own power. So with the passage of time, the transmission lines were developed, and the cities and even now the countries are connected through the transmission line. Nowadays we have a project, HVDC project in Pakistan, where we are connecting transmission line from Peshawar, HVDC transmission line from Peshawar to one of the country, Uzbekistan, in Middle East. So nowadays this is a new concept. Some countries which have cheaper power generation, because they have a fuel, like they have a gas, or if they have a furnace oil, natural resource, they can export directly this electricity to the neighboring countries. And also some countries has too much electricity in winter season, because like in Pakistan, the total capacity usage nowadays is 10 to 13,000 megawatts only, whereas our generation capacity is crossing 30,000 megawatts. So in the winter season we have a lot of spare power, and we can if we have a network, then we can transmit this power to the neighboring countries. So this is the earlier stages, and then there is a in between stages, then where we have a big power plants. Now in the modern era we have a very small micro level power generation, like in domestic level, where each domestic user can export the powers. Here come the use of smart metering, and in smart metering with the use of internet and the latest telecom technologies, it is allowing us to establish a more complex and more distributed level power plants, where the metering can be done through smart meters and through 3G and 4G connected networks. So here the micro SCADA also enabling us to monitor all of these small generations, or all of the distributed power generations all over the country. So the monitoring can be done through this micro SCADA, but normally it is done through micro SCADA, and it is possible to connect such huge networks and monitor them and control them. It is possible. It has become possible now using the smart SCADA and smart metering. So nowadays generation has been transmitted to the as low as domestic levels. It has advantages and also disadvantage, that it has become now more complex, and we need to have a more advanced technologies we need to apply if you want to control and monitor the networks. There are some advantages and disadvantages of integration. So we have discussed some advantages, that if we have a cheap power, idle power available in one area, which is away from the load center, then using a transmission line and using a network, we can supply this power. And another example could be, if a country has so much surplus power in one season, like winter or summer, it can transmit this power to the neighboring countries and earn the revenues. But there could be some disadvantages, because if you are keep on connecting different power plants, different devices, loads to a network, then there is a chance that a fault on a single part of the network, which is also not that much important, can result in a tripping of whole network. This is one of the difficulty. Another thing is, if this network is becoming complex, then it's difficult to monitor and control the power. So there are advantages and disadvantages, but obviously advantages are more than disadvantages. So that's why you will see more and more network connections, and you will see in future more and more HVDC network come into play.